A warm welcome to everyone. I am B. Nagarajan, working in Rohini College of Engineering and Technology. Now, I am going to give a short tutorial on PCB designing. What does a PCB mean? A printed circuit board is an electronic assembly that uses copper conductors to create electrical connection between components. The printed circuit board provides mechanical support for the electronic components so that the device can be mounted in an enclosure. In day-to-day life, we tend to see and use many electrical appliances which comprises of these printed circuit boards inside it. Let's see, for example, PCs, laptops, even our TV remotes have these electrical boards. Let's see, for example, PCs, laptops, even our TV remotes have these circuit boards. So let us discuss the design process of these circuit boards. The first step is to have a clear analyzing of our needs and necessity of the user, for which it can be divided into further smaller parts. This minimalistic design greatly helps in the final assembly and in diagnosing errors. Coming to the design equipments or components that we need to communicate with our phone or through the internet, we can use the Bluetooth modules, Wi-Fi adapters, etc. The another important phase of designing is to use the CAD software effectively. While designing, confirm every part has a schematic symbol and footprint. If it doesn't have, just create your own. Perfectly place every component in the appropriate place on the schematic sketch and diagnose it every time to reduce the errors in the final stage. If it was done perfectly, then comes the PCB part. For the PCB design, we use an insulating material as a plain mechanical support, which is also known as a plain board, and clearly check the design rule before entering a new project. After confirming, place each and every parts on the schematic sketch and make sure that we make a separate polygonal ports for powers and guard. Just diagnose it once to check whether there is errors or not. After this process, we need to interact with our schematics, just like checking all ports having a crosshairs, etc. Most importantly, while interacting with the schematics, we need to be careful while selecting more objects, because right clicking will affect the whole group. If all of these steps are done and diagnosed properly, there comes the wiring part. While wiring, use net tool to make connections. There is no need to make the physical connection, so create a partial net. Then use the name tool to give it a proper name. Use the label tool to place the name right on the net. Always do an ERC when the process is completed to find any mistakes. The next session might be the layout session. Click File and select Switch to Schematic to create a PCB for your circuit diagram. Now create a grid which is slightly larger and a grid which is much smaller using Alt grid. Then use the diagnose tool to find the errors with respect to the designer's requirements. In case of a moving part, everything which are the components snaps into the grid. And we can hold Alt key to get more fine grained control. Try to arrange the parts properly to minimize the rat's nest. Here is the sort keys on the Altium layers. Color red is the top layer of copper. Color blue is the bottom layer of copper. Any part of the green line is exposed copper on both top and bottom sides of the board. The yellow indicates air wires. The right hatch indicates top stop mask. These define where the solder mask should not be applied. The ash color denotes holes. These are usually drill holes for standoffs or special part of requirements. The next process is routing. Here, the operating layer which is presently being used is shown in the upper left. Just click the middle mouse button to switch between layers. To change the wire style, right click on the UI and select Styles. Use bigger traces for power and ground if possible. When finished, use rat's nest to check whether there is any errors. For advanced routing, use polygonal ports for ground and power. The usage of polygonal pores provides good capacitance to reduce noise. It makes routing easier. Use Polygon 4 tool to trace the outlines. We can still route through the pore or hide with a rip-up on the edge. It is also fun to write on the board by editing the cell skin. Again, diagnose it once to rectify errors. When these steps are made successfully, we need to convert schematic to format a PCB. Press the CAM tool button, open job, choose the SparkFun job file, press job, zip the CAM files up and submit to OSPark. For creating a custom parts from the control panel, go to File, New, Library, Symbol, name it and click Accept. It opens an editor similar to our Schematic Sketch. We can draw, add pins and can name a pin using this setting. Click Save and then go to Library, Create, Package. If these steps are followed properly, a custom parts have been created. For creating custom footprints, start by using the SMD or pad tool to place the pads. Set the size of pad with Info tool. Set the grid distance to be the distance is much smaller between the pads for quick and easy placement. After finishing these steps, click Add, click Name, value the text in tname and tvalue layers. To associate a symbol and package, click on Library, click Device, click New, name the same thing as symbol and package, then double click on the package name to associate and to match left and right sides of them, press Connect. Your file is saved and you are done. Find your library files in the control panel, right click and use. Thus, a PCB design with a proper designing diagnostics method is applied. Thank you for giving me a great opportunity to give an overview about PCB designing. Thanks one and all. Thank you.